Awesome. Thank you. How's everybody doing? I know it's the end of a conference, but I would love a little bit of energy. And can you turn this up?
Is it on? It's on?
Can you turn it up? Can you hear me now? Is this better? Better. Awesome. Thank you. Well, so glad that a lot of you could hang out to the end here. We're really excited to be sort of the capstone, the end, for a topic that I know is very near and dear to hopefully all of you and definitely our panelists here. First of all, my name is Brittany Zimmerman. I am the CEO and founder of an organization called Yamay that does exactly this. We look at how we can utilize technologies that were contrived from different industries, heavily from the space industries, and utilize it for climate change. And this is perfect for what we're going to talk about today. So if you came to my panel earlier, you'll know a lot more about that. So for now, I'd like to hand over and do some introductions from these wonderful women. So I'm going to give them each a small fragment of time here to do introductions, and then we'll jump into the topics. So first up, we have Dr. Reut.
Hello. Thank you very much. Glad to be here, being the capstone and everything. I'm feeling honored. Thank you, everybody. I had a wonderful time here. So my specialty is astrobiology. I work in extreme environments, and also I used to work on stromatolite from Shark Bay in Western Australia, so how life began on planet Earth and perhaps elsewhere. I also do cross-contamination issues in space missions, space simulation missions, and how things are spread around in our environment and back forth into the habitat or into our own human environment. I was an astrobiology core lecturer for the International Space University. I co-founded several NGOs in Israel, which are about our future on Mars and how to promote technology and people, and a lot of educational programs that I've been to. I'm very, very happy to be here. Thank you for inviting me for this panel. And yeah, that's what I have to say. Thank you.
Awesome. Sahba.
Hi, everyone. My name is Sahba El-Shawa. I do a few things related to sustainability and space. So I'm currently doing my PhD in sustainable development and climate change, looking at how space can actually motivate us to take better care of our planet. I did my master's at the International Space University, and there I focused on Jordan. So I was born in Jordan. We don't have a space program there. There's very limited opportunities. So focusing on how we can bridge sustainable development with space exploration. And that's why I founded the Jordan Space Research Initiative. We are doing some outreach. We started in 2020, and our goal is to actually build an analog research facility in the Jordanian desert where we can work on these research areas, contributing to life on Earth and Jordan specifically, but also to the future Moon Village and beyond. And the last thing, I'm also a volunteer with the Space Generation Advisory Council. There I'm the co-lead of the Ethics and Human Rights Group and also the Space for Climate Action Policy Group. And I'll stop there.
I'm just in awe. I'm so honored to be here. I just wanted to acknowledge Happy Mother's Day for those who are parents. So I want to acknowledge that first. My name is Dr. Aidyl Gonzalez. I just launched a citizen science project looking at soil quality, atmospheric changes, as well as social justice changes that I'm fortunate enough that Foldscope is also funding the research as well. I am a molecular geneticist, developmental biologist. I graduated from Caltech, postdoc at USC, had my lab at Cal Poly Pomona looking at nematodes. And I also teach high school students, middle school students, elementary, as well as graduate students, learning about social justice using climate acknowledgement.
Wonderful. Thank you. Applause for all the ladies here. Wonderful. Have any of you been in an analog situation yourself? Are you analog astronauts? I'd love to hear about what those experiences were quickly.
So in 2018, I had the pleasure of co-founding with an amazing group of people an organization called DMARS, Desert Mars Analog Ramon Station. And with it, we actually built a habitat from scratch in the Ramon crater in the Israeli Negev. And we did a very short analog mission for 4 days. It actually took 8 months to prepare for it. And it was magnificent. I was the deputy commander and also the science officer. And I remember myself scrambling to get all the experiments done and making sure all the equipment is okay. And of course, no fire was allowed, and all the hazard material, everything had to be kept very safe. And if I had bio-waste, how to deal with the bio-waste in an enclosed environment, and so on and so forth. It was an eye-opening, transformative experience. And since then, I was able to offer, together with a group of people, to offer this experience for other people.
Yeah.
Several analog missions, do some research, like I said, about extremophiles, and also how can you monitor the effect of a human crew on the environment around it. So basically, I had a very nice research going out to do samplings every other day on some places around the habitat and also further away from the habitat, and to see if the soil composition from a bacteria point of view has changed, if some things came back from the outside into the habitat, things like that. We had a lot of limitations, which you usually have in an analog mission. So we didn't have enough electricity, we didn't have enough water was circulating, we didn't have showers, Wi-Fi sometimes was working, sometimes not. And when you're a scientist and you want to record everything properly, all of a sudden you go back to paper and pen, you need that backup. Food was excellent. Food in the Middle East. Food in the Middle East is great. It's great. And it was great. I had a really good team. So that was me in an analog mission in 2018. There you go.
Awesome. Thank you so much. We'll definitely be coming back to some of these experiences as we talk about what we can learn from that. Yeah.
Yeah, I haven't done one yet, but it's in the works, hopefully, with Lunaris this year.
Wonderful.
My analog was in Poland. I did Solaris and Eden, and it was pretty remarkable. My research was focusing on beneficial nematodes, Senioritis elegans, and that's my phone. And asphalti. I could tell you stories about worms. And seeing if they were able to grow not only in earth soil, but lunar as well as Martian soil, and seeing if once I had their material, so like C. elegans like snails and more plant life, asphalti like organic, like mealworms, and seeing that sustainability within that soil and see if plants could grow from seed. And then I transferred that into microgravity. So it worked, but we had very limited scientific tools, so we had to engineer new things. My food was not that great. We have to measure our urine, and our CO2 levels got so high that we had to really problem solve with our life support systems. So in those two analog missions, I was the astrobiologist as well as mission commander.
Wonderful. Awesome. I also did Mars Desert Research Station, so we can pull from some of that, in some of our conversations moving forward, and the inflatable lunar Martian habitat. So I feel like we've got a good sampling here. But first, the thing I want to discuss is in these, and I think you started speaking to it, Aidyl, is in these missions, did we see anything in the terms of life support failure? Because the way that I really look at what we're at right now, right, where we're at in terms of our own planetary existence is we're all on an analog mission right now, right? The Earth is really the habitat that we are surviving in, and we're having a current malfunction with our life support systems. It's not yet critical, right? No life is in danger yet, but we're very quickly moving towards that. So what lessons can we garner from any of the times where we've been in analog, situations where something has gone awry with our life support systems that might maybe help us start bridging that translation between lessons we can learn from those experiences into what we could maybe start looking at scaling for, our entire Earth?
One thing I could say is when that was happening to us, we sat down, made sure we understand what do we need, not what we want. Mm-hmm. Yes, we want cooler air, we want more space, we want better food, we don't want to be urinating in a bottle. I mean, that's what we want, but what we need is better oxygen, lower the CO2 levels, and just making sure that we are working together without egos to sustain not only our vegetable garden, but also figure out a way to revamp our life support.
Awesome, yeah, and I think one of the things that we can garner from that as well, right? We've seen some of the experiments, I see we lost Jane, but even in things that were going on specifically in the biosphere experiments, where not being able to harvest, right, the ways that we expect is has large implications that we can look at, how does that translate to Earth, right? Well, agricultural issues, monocropping issues, where we're losing, the sort of nutrients that we need in our soils has a very large impact for us globally moving forward, just as we've seen happen in a lot of our own analog missions from the past. So the vegetable part is huge. How do we translate, right, from our bioregenerative systems into our physiochemical systems and back and forth, right? These are really important things, and hopefully Sam will help us answer some of those. But yeah, what else do we have in terms of lessons
Maybe
learned?
just one thing to add, because I haven't done an analog mission, so I
Yeah.
can't speak to the life support failure. But the idea that we're not yet in danger or that lives are not at stake, I don't think is true, because we are actually undergoing the 6th mass extinction right now. And that's not just animals and nature, right? But a lot of people as well, vulnerable populations who did not really cause climate change, but are the ones suffering. So I think that's something really important to keep in mind.
Yeah, absolutely. You're definitely right on that, right? We might not all be at risk right now, but we all have major implications, right? We're all breathing CO2 levels that are twice as high as when we evolved as humanity. So major implications. And there's a lot of places dealing with sea level rises and things along those lines also at the exact same time. You're very correct.
Yeah, so I think that it's going to be a bit of controversy here, but basically the planet went through 5 already mass extinctions, and now it's kind of going on the 6th, but it survived everything. So I think the human race might not survive this 6th extinction, but the planet is going to be fine.
Right.
So what we're looking at is sustainability solutions that will allow the human race basically to survive and take good control on the planet. And that's why we're all here in a space in an analog missions, because we think that space might have a few solutions for that. So I'm all for space and analogs in order to find the solutions, but really the planet is going to be fine. And regarding sustainability, I think sustainability solutions comes first from your own environment and from your own community.
Yeah.
So if you can help some of the people in your own community to understand how to have, let's say, like a roof garden, that's awesome. If they can plant like food forests around their houses, so that's really good for the soil, like you mentioned, and things like that. So you can do it on a small scale and help actually a lot of people and future generations without going into, massive, let's do like, satellite imagery over the entire Sahara and understand how we help the things there. So there's a lot of good work to be done also locally, I would say. Yeah, thanks.
Totally agree. And then talking about certain populations in our environment that are not getting the same resources. And this is where social justice and environmental social justice needs to be acknowledged. I was talking to someone here that a bus stop in one area and a bus stop in a more affluent area, they have the same function, but the materials are not used the same way. If you look at the environmental impact, it's warmer in the less desirable areas. There's something else. So there's a social justice impact. There is a purposeful, systemic racism that is involved there, and we need to acknowledge that. So once having all this information, our sustainable agriculture, sustainable materials, once we get that going and saying, hey, each population should have access to it, and why these certain areas don't, then we have data to really talk to our politicians or civil leaders to say, hey, help us out, because we can live according this, as we did as analogs, that we can live with certain sustainable systems in a much healthier way. I don't know what to say. It's just like we at that point, and we need to really be vocal about it. So that's why when you said that, I had to. There's yes.
Yeah, I totally agree. I think also one thing we should keep in mind is that we have this narrative that we need to teach people how to live more sustainably, but there's a lot that we can learn from them as well. When you think about sustainable agriculture, people talk about permaculture a lot and all these concepts that are really not that new, because indigenous communities around the world have been doing them for so long. and we don't listen to them, and we kind of impose our advanced technologies and solutions, which are actually kind of doing the same thing they've already been doing for centuries. So I think it's also, from the social justice perspective, is involving those people more actively in what we're doing and actually listening to them as well. So I think that's something we can definitely do better at in the space industry.
Yeah, absolutely, right? We look at, the implications of utilizing soil amendment products, right? Fertilizers, pesticides, or hopefully things that are more sustainable like biochars, right? When we look at that, we've only come up with the terminology biochar in the last, couple of decades, which is really silly because they've been utilizing terra preta, which is basically the exact same thing, back to the Aztecian times, and they're entire history and civilizations were based off the fact that they came to soils that were not cultivar friendly, and they found ways of creating, right, these healthy microbes, these healthy carbons, nitrogens, and phosphorus, and getting that into the soils so that they could reap the benefits of their crops in their area, but they were also fixing the soils for their future generations. That's still a great place in the world to do agriculture today. And yet we're taking these approaches here, right, in the United States and in a lot of the Western world, and pushing those practices on to other nations that are stripping those things out of the soils and replacing practices that have been sustainable for a very long period of time with things that aren't really, the right way, if you're looking at the life cycle of the whole entire carbon balance. So absolutely. From that too, then I think, in that same vein, that's speaking to soil, can we learn a lot of similar lessons in terms of water, right? Water is a really big resource right now. What can you guys speak to in either your analogs or your past experiences that we've seen sort of on a smaller scale or from ancient civilizations that you think we could apply to the global scale?
So actually, that's one of the biggest problems in Jordan. Because Jordan is very strained in terms of natural resources. We have a very large refugee population, a lot of Palestinian, Syrian refugee camps, and we don't have the resources to support them. And so that's why with the Jordan Space Research Initiative, that's one of our main areas that we actually want to work with. So taking the space technology and our advancements and actually trying to get them to benefit people in remote areas as well. And kind of speaking to what I was mentioning earlier, we have the Bedouin community that they live in the Jordanian desert, and it's their lifestyle, and there's a lot that we can learn from them in terms of how they preserve the water, and also with agriculture, it's very similar.
What do they do? How do they preserve their water?
So I'm not an expert on this topic, but I think it's more the process of the engagement, right? So learning from them, presenting kind of the things that we're doing in the space industry, because it's super similar, right? Like when you're in space, you don't have that much water, you need to preserve it, but you also need to manage how you're using the water. And so, I mean, in a desert environment, you don't get that much rain, you don't have that much access. So I think in that sense, it's kind of similar lessons learned, which I can't tell you what they are right now because I'm not an expert on this topic.
You're not wonderful at everything. Yeah. How dare you?
I'm better at the intersection between things than like, So.
You're wonderful at so many things.
No, I'm good.
Just because I loved how you said the planet will be fine, and sustaining water and learning from the indigenous cultures before us and who are here now. Because one of the themes, at least here, Shumash, I think is here. No, I'm a liar. I'm sorry, I forgot which one. I'm so sorry. Kopi. That water is life, water is knowledge, water is breath. And if we don't have the plants, now that Sam is so important, the plants cannot actually change that water into the oxygen we need. And just thinking about the different types of plants that are currently here that we walked around and saw, the CAM plants, the C3 plants, the C4 plants, different ways that they sequester the CO2, our own natural CO2 scrubber, that we need to make sure that our plants are here in order for the human race to survive. I just like am in awe that we actually now speaking louder to something that was being yelled at so many years ago.
So I think filtration systems and water cycles in an enclosed habitat are pretty important. It's pretty important to get them as clean as possible as well. The time cycles as well are very important because as humans, we actually, on a daily basis, we need what, like 5-7 liters of clean water at least. So you really, really need to get to be very, very precise. You need some sort of precision. What happens actually with the Bedouins and other endemic cultures that are in our region in the Middle East is that they are used to a much wider landscape, and they know the weather patterns and they know the climates and they know the terrain excellent, like no other. So usually their solutions are not comparable to closed environments like the ISS. The Nabateans, which were like a nomad, high society, people who did, like, for instance, Petra, in Jordan, a beautiful spot. So they literally changed the landscape in certain areas to have more water coming through the hills to the different terraces and making sure that they have plants in a climate which has sometimes has only 50 millimeters of rain a year.
Right.
And you still see these plants today, and they grow some fruits, and you can use them for tea, and you can use them for this. So we're talking massive, I wouldn't say terraforming, but it's landscape. It's exactly like what they're trying to do in
It's
Biosphere,
terraforming.
landscape evolution stuff. So if you're looking at massive landscape, terraforming, big stuff, then yeah, you should come to our deserts, and you can talk to the people, and you can learn a lot. But if you're looking at enclosed environments, which are very, very petite in general, which is what we're going to be in the next decade, it's going to be new international commercial space stations, perhaps a base on the moon.
Yep.
They're all going to be like small systems. So you really need to take the lessons you have from the ISS, I would say, and apply them even better in a more rigorous style. And you might have to try, like, I know of new places that are trying to integrate like water, ecological plants, and some fish together into this system, but I think it's still not very precise. So yeah, that's what I think at the moment.
So maybe the better question is, how do we take the lessons learned that we have from ancient civilizations and apply them to our analog missions, right?
The physics are the same. Most of the time, the physics are the same. So how water moves, what are the atmospheric pressure, what kind of temperature do you need, what kind of condensation happens, what kind of materials interact with the water. We heard from Kai so much about this, cement, and when you cure it, and what happened with the water and the oxygen. So that's a really important lesson just there. So basically the physics, you need to take the physics from both systems and find the common grounds. That's what I think.
Yeah, I think, like you said, like, it goes both ways, right? Because we learn from what they have been doing, and it might not apply directly, but there are some ways that we can adapt it. And similarly, the things that we've done in space on the ISS, in analog missions also, how can we adapt those solutions to also benefit them? So I don't think it's not really like a one-way street, right? Like, it's a relationship that we need to have with these people who unfortunately are not very present in the space industry for a lot of reasons, but I think it's on us to make it more accessible to them. Like, even these amazing conferences, not everyone can attend these conferences, not everyone can afford to fly out and take part in them. And I think that's why we should have a more active role in terms of who we involve in our discussions.
Yeah, I know, because we were talking about that, who is not at the table, and make sure we seek them out to come in, because more diverse thought bring more diverse innovation that bring humanity forward.
Yep.
But exactly, yeah.
Collaborative approaches, right? Really, it's about bringing all of the different minds together and having these conversations. So one of the other things that I think is really important when we start talking about, right, sustainability and how does that apply to climate is, right, we've talked about a little bit, about the water issues. We've talked a little bit about the soil issues, and carbon is kind of the other, one of the large ones right now, which really plays into both water, right, and into the soils. We have seen some catastrophic lessons learned in a lot of our more closed systems, right? In what happens when we don't understand those reactions, right? When we don't understand that calcium carbonates are going to be, sequestering oxygen and carbon dioxide, right, out of our environments, or how off-gassing is going to affect everything. Well, sure, we do have an open environment here, so to speak, but I mean, even that is, right, like a sponge. We can use up all of our sinks that that we're utilizing right now in the form of our oceans as a carbon sink, and in the forms of our sediments, right, as a carbon sink. And whether we're balancing everything correctly or not is pretty obvious we're not. Yeah. So one of the things I would love to hear about, some of your guys' past experience, I think, can speak to this, and maybe some of the past experiences in places like Jordan, is how can we utilize not necessarily advanced technology like we're moving forward to, but what lessons have you guys found through the research that you've individually done that can work on sequestering those carbons in some of the, natural places that are not the oceans?
Okay, I'll start. So I think that's not really my area of expertise again, but I think what I learned, so I did an internship at the European Space Agency, and their Clean Space office focuses exactly on the environmental impacts of our activities. And there we did life cycle assessments for launchers, but it really applies to everything. So when you do a life cycle assessment, you don't just look at the carbon emissions, right? You're looking at a lot of different factors. And I think what we often neglect in these conversations is that even if you do have the most amazing technologies that can capture all of the carbon and fix everything, they actually can't because it's the problem is really much deeper, because if you look at the biodiversity loss, the resource extraction, the way that we interact with nature, which I believe we are a part of nature, but the way that we interact, the way that we exploit nature, it's just going to keep that cycle repeating. So I think it's good that there's a push for net zero emissions and things like that, but I don't think that's really the solution.
Or the only problem, right?
Exactly.
Even if we were to balance our carbon, we still need to readdress the way that we're interfacing with nature and other species. Mm-hmm. And as soon as we get to the point where maybe we're not forcing our own extinction, right? We still need to pay attention to the extinction of the other things that are sharing this planet with us.
Absolutely, and it's all interconnected. So mm-hmm. when you're cutting down trees, you're also impacting the resources there. You're impacting their ability to do the carbon capture that is natural already, right? Yeah, so I think that's why we need kind of an all-encompassing change in the way that we interact with nature. Mm-hmm. And that's why for my PhD, even though my background is super technical, I'm an engineer, I did space engineering, systems engineering, but in my PhD, I'm looking more at the philosophy, the psychology, the ideology behind what is causing climate change, what is sustainable behavior, how do you even define that, how can we as a collective be more sustainable? Yep. But I don't know about if someone wants to add about the technological.
I'm just thinking rubisco, that protein. It's like, you're right, that's all I'm thinking.
You should tell the crowd.
Yeah. So rubisco, it's an old enzyme that hasn't changed, right? Since we came to think of the plants, right? And basically this enzyme could take inorganic carbon and make it organic. I mean, that's amazing. And if there's a way, I mean, it hasn't changed all this many years as autotrophs, came to play, and heterotrophs. That's all I'm thinking about. Is like this natural enzyme that helped sustain us to be on this planet to make sugar hasn't changed, and can we learn from that? And that's right now I'm geeking out because all I'm thinking about is Rubisco started it all. And that's my geeky moment of the
Well,
day.
what's the current state of this Nabisco, and
Oh,
how have
Nabisco
we
is all over the
affected
place.
it, or what can we do?
So from what I've read so far, please, if anyone knows, please share. I haven't seen any changes with rubiscos. I know there's been some type of taking this enzyme and try to perfect it more and sequestering. Naturally, we have these 3 types of categories of plants, C4 and CAM, sequestering, the carbon dioxide
Right.
and just having a holding pattern.
Yeah.
In the Calvin cycle, if you could tell I'm a high school teacher at the same time. That's all I know right now. And wondering if in the ISS, are they altering the rubisco in order to reduce the natural CO2 levels? And that one I do not know. I need to research better.
They haven't done that, but they are looking into biological components inside the ecless. For instance, different types of algae and how you put it in and how that sort of like helps you with atmospheric. Same as plants works, algae works the same, but it's still very much in its beginning, and there's no plans at the moment that I know of to actually integrate an ecless or a let's say a plant nursery into the ecless. It's a bit of a 2 different system. The ecless was always designed by engineers, and all the rest by biology people. So we're still looking to do the integration of those things, and they hold big promise, because if you combine the basic understanding of what these things are doing and you apply some genetic engineering on them, you can actually multiply and by many folds their capabilities. So you will have an ecless which will have all of a sudden fresh O2, and it will be, sequestering the carbon like you're talking, and it will be it will be very important and might have a less energy consumption than you would have from all the current, filtering and ecless system that you have on board.
Yeah,
So
absolutely.
those are very interesting avenues of the research, and I'm looking forward to hear more about it. Yeah.
Yeah, in the International Space Station, they also have high exposures to radiation that we don't see here. So we see a lot of different things happening in terms of our microbe mutations, right, in flora and fauna. So it feels like this is one of the really nice places where we could actually use analog missions that might give us more relevant data than we actually could get on the International Space Station. So that's a really great spot where maybe we could look at, how could we pull together some sort of a team that looks at, what research needs to be done, in these analog facilities that is not only relevant to the space industry. We look at that currently, right? But what lessons can we learn from those experiments and apply them to what we're doing here terrestrially, right?
So there's actually an amazing house, I think it's either in Hamburg or in Munich or in Berlin, that entire apartment building is based on energy from algae. So there's like massive bioreactors at the bottom of it, and you have like these pipes going up and down because you need to catch, the different temperatures and then how the sun travels during the day and things like that. And it somehow produced all the biogas that you need for that house.
Yeah.
And it was a demonstration that was supported by the city, because the city wants more green energy, and they told them, look, this is the calculation, it's going to work, and it works. And it's an amazing website to see like a house that it's like an apartment building that it's completely off the grid and works on algae. That's weird, but it works.
Awesome.
Yeah. So there's huge advances on Earth with algae-based bioreactors, sometimes for food, but also for energy. So you can look that up. That's amazing stuff. Yeah.
Absolutely. Yeah. They also did like the BIOS-3 and BIOS-3M experiments out in Russia, right? And they did some really long-term closed environmental studies there, that I think are almost on par with what they've been doing, what they did do in the biosphere too here. And one of the studies that they did specifically looked at algal production, and they pushed to try to get their astronauts to feed on the algae that was produced, because it was helping obviously with the ecosystems, because it's helping with the gas exchange. And so they found that you can supplement an astronaut's diet by up to 20% with algae. After that, it gets a little wonky. You might not want to push the bounds there. But it's really interesting, because when I went to go dig in and look for more information there, almost all of those studies are in Russian, right? So
they did massive stuff, yeah.
Yeah,
but
I don't
also
read
some of the earlier research came from the American Navy.
Yes, absolutely.
In the 50s and the 60s, I think.
They did a lot of high altitude jet pilot testing in algae as well. They've done some really cool stuff. So we've, I think we kind of fall victim also to repeating a lot of experiments that have done before, just because we don't have, a base to go to and find all of those lessons learned. So that's another thing that I think we could do a lot better moving forward, right? Is sharing the lessons learned that we get, because my specialty might be bioregenerative physiochemical hybrid systems. So I'm looking at how do the plants interact, right, at an environmental level with the physiochemical part of this, and how do I transition? But the results from that might have like really large implications on what's being done, at the microbe level. But I don't know that, because that's not my specialty. But we forget to have conversations and start looking at each other's work, because we don't immediately see the relevancy in it, when there really is a lot of relevancy and crosstalk between a lot of these areas.
So I 100% agree that we need more collaboration and more transparency, I think, in the space industry as well. But one thing that really limits us is that a lot of this data is not accessible.
Yep.
So when you talk about, experiments done by the Navy or NASA, or because it's classified as like defense and space, and when the military gets involved in anything, the security restrictions are a lot higher. So the problem there is that a lot of people who are working on similar things they're not able to have this conversation unless you're from a specific nationality, or you've gone through the process of coming to the US and going through, it's even when you become a citizen, there's things that you still don't have access to, right?
Yeah.
And I think that's a huge problem in our industry that limits us, because if you think about the applications of space technologies, there's so many for sustainability, for life on Earth, and then there's the dual use side of things, and unfortunately, because the military funding drives a lot of it, it also imposes a lot of restrictions on who has access to this data. So I think that's something we can definitely improve if we want to, like you said, actually share this information, actually not repeat a lot of the same things, because they have been done. It's just that not everyone can access that information.
Absolutely. And as we dive into that conversation too, it's really important, it gets kind of philosophical, right? What is the role of government and their responsibility, and what is the role of the private sector? And if the government is funding a lot of these and they see value in it and it needs to be protected, right, where is the line supposed to be drawn between what is shared and what is not? Is there a, that's a much harder route to take. Is there another path that we could take that could increase, right, like private financing from, the sectors where that information can be shared, without the same red tape and without those same restrictions? And I think we see a lot of push in the private finance realm right now to support these ESG, clean tech, climate initiatives, which is fantastic. We're seeing more sustainability officers pop up, in offices at organizations that we've never seen before. So there feels like, they're hearing us a little bit, in that at least outwardly they're trying to make it look like things are being done, right? Which I guess is one step in the right direction. But what could we do, right, in order to build up more momentum to allow the private industry to kind of take grab of that initiative, so that we can run forward with it without having to rely on information, that is buried in the government?
I don't think there's an easy answer to that question. I mean, I think what we can do as people in the industry is actually, first of all, have these conversations, understand where those barriers are, and then if you have a chance to do something to create opportunities for people who don't typically have that access. So that's what we're trying to do in Jordan, because we, for countries that don't have a space program, sometimes it's not even just, oh, they're military applications, so you can't access them, but it needs to go through the government route. And if you don't have that kind of agency in your country, then you're also limited from participating in the space industry. So that's where I think, like you said, the private industry, nonprofits, analog research is a lot less restricted.
Absolutely.
So that's why I think it's a good kind of, it's a good opportunity to get started in that direction. I think it's very difficult to completely, separate these things, but we just have to do what we can.
And that's perfect, right? I mean, we have access to large communities of analog astronauts, and a lot of the people we've seen present over this whole weekend are privately owned analogs, which is fantastic. So maybe that is one of those perfect avenues where we can start pulling together a lot of that information and seeing how we can utilize it to better the climate and all of our other existential issues that we're facing right now.
Which are all connected.
Yes, they are. Absolutely. And then I know we're getting short on time, but I would love to, is it okay if I open it up to the audience? I know we probably have a lot of questions. And any final words, ladies, or parting ideas that you'd really like to drive home? All right.
Just keep on communicating. That's one thing I want to make sure. Just communicate.
All right, cool. Thank you so much for talking about this. I love it. I've been taking notes furiously. My question was, I'm putting together a database of resources for people who want to build electronics sustainably. I'd like to cross-link to other knowledge bases, basically, and you were just talking about how a lot of this stuff is kind of locked up. I'm a hugely passionate advocate of open source technology and things like that. I'd love to hear about any public databases that you know, or knowledge bases around this kind of thing, like what technologies are being shared already? Where can we find those?
You have some? I just know like my little world. I just have my little, I know the data that I'm receiving is open source. So it's citizen science. So if you look at Soil Science Lab, that's all open source. Anybody could put in data. They put their coordinates, the soil quality, the atmospheric quality, and the nematodes found, because worms are the way for me. You will find that's open source. And I really do like Zooniverse. Zooniverse do have a component that all their data is open. So in my world, that's what I know for sure.
So there is, with the European Space Agency and with NASA, they do have some stuff that's open source. So we did a rover design competition last year, and the students in Jordan have absolutely zero access to any of these things locally. And so we just shared a lot of the things that, I don't think NASA is going to share all of the details of their designs, but they do have kind of the educational version that you can make, and they're much more accessible because you can use 3D printing, you can buy some of the kits to put it together. So there are definitely resources like that depending on the application that you're looking for.
The thing for you that I can say, there's a really nice guy called Kartik Kumar, and he has a website called also Sat Search, and he actually, specifically for satellites and things like space simulation missions, it's an open database. So you should totally look for the electronics part in it and get in touch with Kartik. Yeah. He will happily help you. Thank you.
Awesome. And the last thing is, a lot of universities have data that's open source as well. For example, for 24-hour blocks, you can see all of the information that's collected on the sensors in the biosphere too here. You'd have to go in periodically to get that data yourself because they don't store it without partnerships, but it's open if you're consistent about going in there and taking a look, and a lot of universities follow this format. Awesome.
One more thing is that Azure by Microsoft, they have a really big IoT sensor stuff going on, and through there you're going to find heaps of databases as well. And it's pretty much open, I think. Check me.
Just a quick comment, coming back to the understanding that our world is changing, our ways of life will have to change eventually. And I would argue that we can regard to life in space as an analog to the way we should live here on Earth. Which leads me to the thought that analog missions might be also communicators of space technology, streamlining the technologies and developing better user interface that could be better proliferated on Earth to the general population. This might be a good additional added value to analog missions.
Absolutely.
Yeah, exactly. That's exactly what we're trying to do in Jordan. So as I mentioned, with countries that don't have a space program, they don't have the resources, it's important to show this link, because otherwise you can't justify spending money on space technology. They're not going to send the first Jordanian to the moon just because we want to send someone to the moon. Like, that's just not reasonable. And I think oftentimes in the space industry, because we all love space and we're all so excited about it, we're like, yeah, of course we should be doing these things. But if we actually listen to the people and their issues that they're having on Earth, we can sell it to them in a way, right? That if you use space technology in the right way, then it will help life on Earth, which isn't to say it always helps life on Earth. Like, that's just not true, but it can. So like any technology, you can use it for good or bad. And I just think it's on us to find those applications and to do it the right way.
Any more questions? In that case, thank you all so much.
Awesome. Thank you, ladies. Thank you. Thank you so much.